Hello and welcome to the Mirror Life. Though mirror biology might lead to improving drugs and other innovations, scientists have warned against potentially devastating consequences of this research. Scientists are considering what limits to potentially place on mirror image cell research. Scientists have been voicing concerns over the creation of mirror life. Synthetic organisms made from molecules that are the reverse version of those used in nature. For some time in December 2024, the interdisciplinary group of 38 scientists penned a warning article in the journal Science, arguing that mirror life would pose a great risk to ecosystems and human health. Life on Earth depends on building blocks that are chiral, which means they are oriented either left or right. DNA, for example, is made from right-handed nucleotides twisting only in one direction. Proteins are built with left-handed amino acids. That's me, left-handed. But in mirror life, it would all be reversed. The nucleotides that form DNA would be left-handed, and there would be right-handed amino acids in proteins. These molecules would behave the same way that natural molecules do. And that's why scientists say they could get out of control. Last week, a group of leading experts in synthetic biology and microbiology gathered in Manchester, England for an international conference, Engineering and Safeguarding Synthetic Life 2025. There, they debated the risks and benefits of creating mirror life. Later this month, the U.S. National Academies of Science, Engineering, and Medicine will host a similar workshop regarding mirror biology. Pretty much everybody agrees that mirror life would be a bad thing, says John Glass, a synthetic biologist at the J. Craig Venter Center to Mark Pablo at Nature. While creating mirror life forms is still decades away, scientists are discussing it now because they hope to research the consensus on limits and guidelines to mirror life research. In some ways, mirror life could be helpful. If used in new medical drugs, the reversed molecules could prove more difficult for our body's enzymes to break down, giving those future drugs a potential advantage over the drugs of today, as Molly Glick writes on Nautilus. Beyond pushing drug discovery forward, mirror image research could create enzymes that might degrade plastics, writes Tenzu, a molecular scientist at China's Westlake University, working to build a mirror image ribosome in a commentary for Nature. But even those organisms could be harmful. It is not just mirror image life that we need to be concerned about, Zhu writes. Mirror image molecules that turn out to be toxic or pathogenic are so useful they could become pollutants. Could be hazardous too. These molecules could, for instance, infect people without triggering an immune system response, then spread even further. Without any predators, mirror bacteria could proliferate through the environment. Kate Adamala, a synthetic biologist at the University of Minnesota, tells Nature that the pursuit of mirror image life is not worth the risk. There is no benefit of mirror biology that couldn't be achieved other ways with normal biology, she says. Adamelia, I cannot say her name, tells Nadia Yancey Bragg at USA Today that she would like to see a treaty banning the development of mirror cells around the world. While she thinks that passing such a treaty is unlikely, she hopes that individual countries and organizations can agree to stop the pursuit of mirror life. Zhu, on the other hand, calls for more dialogue. Scientific exploration is not a glamorous march toward increasingly precise understandings of the universal truth. It has a long and difficult history of trials and errors, uncertainties and risk, controversies and doubts, he writes in Nature. Yet through rational dialogue and objective analysis, a responsible, open, and rich human adventure can be charted for the world of the unknown is infinite. Thank you very much.